Okay, I think we're live. So hello everyone. Welcome to another day where we do 3D game engine in Go. It's been a while, but been a bit sick and busy things. So we'll try to do what we can today. Hopefully I feel well enough to do something. And yeah, so let's pick up where we left last time, where we were working on the entity component system, which I have up right here. Let's just run everything. Then we'll go. So everything is working. We left it, but this is not changed to the new entity system yet. Not yet. Okay. So what I want to do today is hopefully finish up our entity and registry, have something proper here, so we can create a new entity. We don't use generational indices yet, which we discussed last time, and we don't have a free list to make this more efficient. But yeah, so far, so our entity right now is just an ID and in 64, and we wanted to kind of separate, use the different bytes within this integer for different purposes. So we might mark the generation of the slot, some flags, and then the actual index in the rest of it. We might want to make two fields for the flags, but we'll see. And then, so we have add component, and we do get components, get all components type. This is fine. Artifact entity. All right. And then the register. I think this is where our work will focus on today. Yeah, which is just being, just we're live. Okay. So where should we start today? Oh, and we had a bit of test code, so might as well enable this so we can see. So our test code was just creating a new level and saying, well, I want this many entities maximum. I do want this to be dynamic. And then, the rest of this, or just checking if there is a component, which I think transform is there by default. And then we are adding a bunch of new things. Is transform there by default? I don't think so. Let's run. So yeah, we have nothing by default, and then we add a bunch of components. I think that's our transform with position, rotation, scale. Yeah, okay, cool. So where do we want to start for today? I think the IDs, and then like a free list and an expanding entity list. So registry is nothing more than a bunch of entities, an array of entities. Kind of works like literally in this case. So when we request a new entity, we try to grab a free one, and then when we free something, we get it. Okay, so right now we're using ID 0 as being marked as free. All right, so we're using new entity. Okay, so I think let's start with the generational indices. And if I go here, actually this is fine, keep it here, I just want to take it. This is how we want each ID to be. So when we create a new entity, we want to increment the generation, set any flags, and then do the index. So first we need the flags. I think on the entity itself, Let's do like entity flags, and it's just an integer. Actually, since we're using only 1 byte for this guy is just going to be a uint8. It's a byte. It's going to be 1 byte. And just do entity flags. And what do we want? So I'm thinking whether to have a flag to say this is free, a free slot, or not. Or do we just rely on the ID being there, being 0? No, I think ID being 0 doesn't make sense. Yeah, it's not enough. Maybe. Yeah, we cannot do ID 0, I think. Because how do we know then the generation? So we'll put a flag like free or dead or something. Dead, maybe. And this is just an entity. Oh, it's been a while since I did Go. Entity flags. So maybe this is iota +1, and we'll keep 0 for unknown. So we have unknown 0. Should we use 0 flags for default? You're just alive. I think so. So dead. Let's just do simple things for now. We can change later. So I'll use 1 for dead, 1 for alive. If it's alive, it's basically taken. If it's dead, then, you know, actually use this for dead. And this guy, let's say atom by 0. 1, 2, 4, or 3. Let's see. It's 1 moved by iota. So this should be 1. I do want this to be 0. So this equals 0. And this guy starts at 1. So 0, 1, 3. No. 1, 2, 4. Yes, this is what we want. Okay, so we have this. Sign type, type, please. There we go. So you have dead and alive. So when we create entities, they are default dead, which I like, and then we can add more. Now, what was doing? So we have our flags. The generation does start at 0, which is fine, and then we just have an index into this array to say, hey, which one it is. So when let's see, when we go to grab an entity, we just loop, and what we need to check is we need to grab off these things. So let's do this. We need a mask for each one. So you have I guess the top byte being generation, and then the second byte being flags, and then the rest being the index. So if we want to say generation mask is equal to, let's see, so we want to shift this by 7 bytes. to move it into the lower byte so we can read it. So we're going to shift shift by 64. No. 64 minus 8, I think. It's not a mask. Shift bits 20. Generation. So if we have let's make a function. So get generation from ID, and we give it an entity ID 064, and we give you a byte. And all we have to do is return entity ID shifted by the generation shift bits to the right, which I think, yeah, just we shift by this much, and then we simply cast 2 bytes. I think so. It's gonna be public from entity ID. Might make sense on the entity, all of these things. Yeah, let's put it on the entity. On E entity. So E.ID go. So now we can test something. We have an entity. Let's put the ID 1 shifted by 64 minus 8. Right. So I'm putting 1 the top bit of the on the first bit of the top byte, and then if we print e.get generation, we should see generation 1. I think. Let's run and see. Hopefully, yes, we get a 1. That's good. If I shift by less than that, then I should just get 0. 2. Shift 1 shifted to the left by, oh yeah, this is correct. This thing is 0. And 6 give us 4, and so on. Okay, so we have we do have the generation correct, so we can get the generation. And new entity, what we want is now to also be able to get the flags. Get generation. Get flags. And flags are also 1 byte for us. And for this, we're going to use this. So we have one more, which is the flags shift bits. And if we want to get the flags, they are 16. From the top, flags are a bit more complicated because we have to shift them down and only get that part out. So we need to shift. Okay, yeah, we move it down. We convert top bytes. Flags shift bits. Then get flags. Let's move this up. We're going to move by flagship bits. They convert to a byte. And then last thing is, if we want to get, what do you call it? The index. Get index. Index is how many bytes? It's more than 4 bytes, so we're going to be returning an int 64. And we don't need to shift. It's already shifted. It's already in the bottom bytes. We just need to read it. So what we need to do is we need to clear the top 2 bytes, the generation and flags. Or we can shift twice. Let's clear the top 2 bytes. So we can do index mask. So I think we'll do like 0x 0 0 0 0. We are clearing those out, and then first byte, second byte, third byte, fourth byte, fifth byte, sixth byte, and seventh byte. 1 2 3 4. So 1 byte, 2 bytes, 3 bytes, 4 bytes, 5 and 6, 7 and 8. So we're going to take this. We're going to return the ID ANDed with the index mask. We will call it index mask. And that's that. So now, if this guy wants to do something, what we are going to do is we say, give me the entity and get me the flags. So flags. Then we can say, well, if the flags, we can make this easier. So we can say has flag turns a bool, and what you give us is an entity flag, right? Yeah, entity flags. I think entity flag is better. Okay. Zero is a problem. That's, yeah, this has to be 1. Because we don't know if it's set or not. This is maybe unknown. Nothing. And 0, and then we start over. 1 and 2. Okay. Then 4. Okay. Yeah. All right. So you send us a flag. You say, does this exist? And all we have to do is first e.get flags, and we AND with EF. We say whether this is bigger than 0. I mean, we can return. There you go. So if, for example, if you guys are not used to this, what we're doing is we're using each bit as a Boolean, essentially, 0 or 1. So if the bit is set, so in this case, the first bit is used to say if dead is set. And you can actually have multiple fields set at the same time. And when we want to check them, we just AND the bits. So we AND the first bit from here and the first bit from here. If they're both 1, then you will have a value that's not 0, and that means the flag is set. But But if they get zeroed out, that means the flags were not set. So yeah, you give us one flag and we check it for you. So here we can just do fe dot flag, and we can say if it's dead, right, or if it does not have this flag, then continue. We can say if e dot get flags equals 0 or equal entity flags dot unknown, or it's dead, right? We can prove this later. So if we have this, if it's not unknown and it's not dead, we cannot use it. Yeah, it's not unknown and it's not dead, so we can't use this. Otherwise, we can use this spot to give out the new entity. And to do this, all we have to do, entity counts, yeah, it's fine, we keep it. So the ID is going to be made up of 3 parts, right? We have the index, which we know. The index never really changes. I think we have an index, we have the flag, so we're going to set the flag, we're going to increment the generation. Then we can say maybe func gets new ID, right? And this can return to us uint64 get new entity ID. And what we can do is we'll give it create new just name generation is a byte, flags both are bytes, and we give it what's the index you're using, right? And all this is going to do is essentially we'll use the index as base, move this up, and it, and then and it, and this one. So what we can do is index and first uint64 generation, and we're going to move this by how many? The generation shift bits, and 64 index, not index, flags, and we will shift them up by flags bits. Yeah. So you have the index in 64, we take 1 byte, put it at the top, and then 1 more byte, put it there. And that should do it, I think. So, so right here, what we can do is the new ID is equal to new entity ID. What's the generation? Well, generation is e dot get generation, whatever the old generation is, plus 1. It was generation 0, now it's 1, and so on. The flags, we are going to set only 1 flag, which is alive, and index is I. Index is, yeah, just I. There we go. That's it. Okay, and to test, what we can do is say old gen old flags is e.get flags, then index, right? Then we can print. Let's do printf all gen to make sure we got the math right. These are all decimals, all flags, and index, all the index, and then the new ones. This guy is all gen, all flags, index. E dot get index. Index. Now we repeat the same thing. We just do gen flags and index, and then we can use the. So now the ID is outdated. We should be able to get all the new stuff. So what's the generation? What are the flags, and what's the index in the array? And in here, when we call it, we should get the new stuff. Let's see. And we have an error. Entity ID must not be 0. Wow, it's remaining 0. It should not be 0. The ID must not be 0. Old is 0, new is 0. Okay, something's wrong. Let's see. So the old stuff are all 0. But we did a +1 here. Should have gone up. All right, so I think what's happening is, yeah, because when we are ANDing, this is not an AND. I think this should be an OR. Yeah. Yep. Because the index right now, the index is filling the lower bits. The generation is the upper bits, for example. And when we AND them, the zeros of the generation cancel out any numbers of the index. They all cancel out. We are combining things. So what we have to do is OR these guys, and I think this is it. Bit operations are always a bit finicky. There we go, nice. So we have flags set to 2, generation of 1 as we expect, index is 0, again as we expected. Before it was 0, 0, 0, now we have some nice stuff that we are setting and extracting. And flag is 2. If we look at alive, alive is 2, exactly. And 0 before it was unknown, and unknown is the default state. There was no flag set, it's a new entity. So this is nice. So now we have some generational indices. They're not used, but we have like the special kind of index, not this one, but the IDs. Right. So we can do this. Now we don't need these guys. We can use this as tests later on, do some unit testing. Let's see. ID. So here's how you grab a new entity. We loop over some entities, we grab one for you, and that's that. I want to free entities, right? Let's do on the registry free entity, and you just give us, well, here's an entity. I don't want it anymore. I'm done. And let's see. I think what we can do is first we need a get entity. And what you give us is an ID of an entity. and we give you back an entity. We can use this to ensure that the entity ID is actually valid still, because maybe you're referencing another entity and that entity got destroyed. So now when you go to check it, you should ask the registry to give you the entity, and if the entity is not there, it's your job to handle this. And how the registry is going to do this? Well, now we have generation, we have indices. First step would be, what do you call it? Is we essentially want these things. Get generation. I want to reuse these guys. Or we can just do entity. We'll just move them to be pure functions. Get generation, and you give us an ID 64, and what do you call it? ID. That's it. And get flags ID 164. And get index. Get index ID 64 ID. And that's not here anymore. e.id and bytes. Yeah. Come on, Go, you can do it. OBS Code maybe. And get entity. So what we can do, oh my god, it's completely dying here. All right, what's up? Why is it? Okay, get entity. So first we're going to do get generation, and we give this ID. Now we know the generation, and we can do get index, and what we can now do is we can get an entity using the index. So we can just do entities lookup by index, and now we can check the entity generation by doing get generation of EI, right? Now, since you're trying to grab an entity, if your generation, you might have the same index, but if the generation is wrong, then you likely have an old entity, right? So if your generation is not equal to E generation, we're going to return null. Otherwise, we got the entity you wanted. There you go. Take it. This is a pointer. And that should do it. That should do it. Right. So now in free entity, I think we should validate entity first. We can even just take an ID, honestly. Essentially, I want to do the same checks. Free entity. Free. Should we take an ID? To repeat this. I think we'll take an ID UN64, and first we'll grab the entity, get entity ID, And if E is equal to null, then we assume it's already freed. Either it's free. Actually, no. So it's a question of, do we return pointers as one? And what do we do with, because if you give us an ID, we always free. We have no way of knowing, like, are you freeing an all thing? We do. No, I think this is valid. Yeah, this is valid. So if it's null, then your entity is not there anymore. It's good. And let's see. If we get the entity, it's not there, that's done. Otherwise, we have access to the entity. We can now set it as clear. So you can say ID equals ID equals new entity ID. I think we can do it this way. Get generation. So I'll keep the generation e.id. All I want to set in this case are the flags. I want to say now in this case we have entity flag dead. You have freed it, it's gone. The index stays the same, so get index is just the same. e.id. That's it. And since this is a pointer, next time we come over here, we loop, we're not going to find it. e.id. Get generation. e.id. That should do it. Nice. So we have get entity, we have free entity. Just simply a matter of setting some fields. So now anyone in the future after this call who tries to grab the entity is going to just get null because the generation is wrong. Now, obviously, this is not perfect because after 250 times where you free the exact same entity and it gets reused, what you're going to end up with is, what do you call it? It's going to loop back. So if you have a really old entity ID and you're storing that and you ask us for it, we might get confused. But there are ways around this. For now, I think this is good enough. Oh, and we need to decrement entity count. Although I'm not sure, how useful this entity count is. Let's see. Yeah. Now there is the thing of, instead of looping like this, every time we free an entity, we can add it to, what do you call it? To a free list. So for example, a free list can be as simple as something like this. Free list item, maybe. So all we have is entity index, which is unit 64, and next free to the free list item pointer. And all this does, it's a very simple idea, but I think it's very nice. So a free list is this. So when we come to grab a new entity, what we can do is check the free list first. So the free list is like, here is an entity that we know to be free, right? And here is the one after, if you use this. So instead of looping over this, we can just literally grab the first thing on the free list, remove it from the free list, and we're done. We don't need to loop over a lot of already set entities. Yeah, we can do this. So what we can do, if the free list is not equal to null, so we have at least one item in the free list, what we can do is, so we just need to grab it. E equals r dot entities, r dot entity index. I mean, it's the same size, a pointer here, and let's keep it for now. It's fine. We can grab this, and then we need to remove it from the free list. So the free list is equal to free list.nextFree. This might be null, maybe. So where our free list is completely full, empty, like used up, and next time we have to go through this or not. So maybe we have like entity to use. It's just a var entity pointer equal to, right? And in here we can just set it and then in here all we have to do is find an entity to use equals E, and we can break, and then the common stuff is all this. So if entity to use is not equal to null, if we have something, maybe let's switch it up like this. We couldn't find anything to return, then just go away. In here, if just do an else. There we go. So if we have stuff in the free list, just pick the item immediately, and you can see this is a lot less work. We immediately grab it. Otherwise, we loop and we check if we have anything free. And once we have it, we can do the common stuff of all this. Updating the ID. Oh, the index. So the index never really changes, I don't think. So for now, we can just do get index. That's it. There we go. And then we return. Right, so either grab from the free list or do this. Now for now, we're not using the free list because no one is adding to it. We fill it up here. So once we have something free, marked as dead, all we need to do is free list equals a new item on the free list. And that item, the index is, so you can kind of save it, the index. This is the index of the thing that's free now, and it's pointing to the free list itself. Right. So we replace the first item with this thing. So now this thing is pointing to the thing before it, and the thing before it points to the whatever. Right. We have a full kind of linked list of things that we can use. Entity count. So over here is good. Get entity just has to check this. I think this is is a good start. Let's check that. So we have a new entity. This is the test, right? So what I want to do is check, like, okay, get me maybe E1 and get me E2, and then perhaps registry.free E2, not free list, free entity, E2.id, let's free this, and then next time So I can do E3 new entity. So what this should give us now, since we got an entity, we freed it, this pointer is invalid now. Like it is valid, but you know it's an old entity. It might have changed to something else right now. That's why you should always store not the pointers. If you're not that entity itself, you should always store the integer, the ID only. And every frame you want it, you just go and grab it. You say, please give me this entity. But essentially, we grab this just to check now. Look at E3. Since we're getting from the free list, E3 should have the same pointer as E2, but it should have a different ID. This is what we'll check now. So print line E2, E3, and E2.id not equal to E3.id, because the generation changed the rest should be the same, but the generation should change. That's the difference. That's a different pointer. Well, we can step into it. Oops. Hopefully it builds fast. This is weird. I think we should be clearing the list of components as well. That would make sense. At the very least, emptying the array, like just slicing it to 0. So you don't get a list of pre-existing components already. Yeah, we should do that. While this is building, we can do oops, okay. So E2 is this thing. Now let's step in this guy. Exactly. We're getting entity to use. And let's see. I think this is the same thing, right? 38592. And in here, no, that's not the same. ID is 7262. Yeah, that's a different ID. Oh, okay. It seems the generation was. That's the only difference I see. This one is. It's one more generation. The generation was increased, I think. What does free do? Free gets index. It keeps the generation. It keeps the index. It just flags it as dead. Although dead should be like a 0. But okay. Let's do this. So now free list should be null. Yep. Because we don't have anything more. Entity to use, entity count, read the ID. Interesting. Interesting. 1 and 2. Let's do here on free. Okay. So ID 102. Come in here. same ID. So tell us the pointer. Okay. Edit count, get index 0. It should be index 1, not 0. Wait, what's happening? Okay. Are we giving it the same index twice? Right. Okay, let's do E1. Can I get the pointer of E1? Just the pointer value. Okay, so this is, but I think this is clear that this is index 0. All the lower bytes are 0. And then we get E2. And now they're both the same. We're getting the first index again. The first entity is being returned in new entity. New entity has a mistake. So this is the second entity. We should be getting no free list. We're coming here. Continue, exactly. And then we're coming. Okay, correct. Right, so the index is wrong. Yes. Yes. Is correct. So this is why. Here we used whatever index was set on the entity, but I completely forgot that all the indices of all the entities would be 0 in the beginning. So we actually need like an index. So entity to use index, and this is a uint64. And then when we grab it from the free list, it's nothing more than the entity itself, because we assume if you went to the free list, you already have a valid index, right? And we can do like get index, whatever it is. Hey, we actually already have it in here, the index. There is the index to use. We can use that same index in here, and then we move the free list. Now in here, the difference is, well, entity index to use is I as an N64. What's wrong? Is used? Yeah, interesting. And in here we can do that. No need for get index, we just use it. Now, the first time we get an entity, we always ensure that it has, not just the first time, but anytime we go through this loop, we ensure that the entity has a valid index. Because when we generate, we're going to say, this is the index you use. If we grab it from the free list, we already know the index, so that's done. And now we should get the behavior we expect, hopefully. Yes. So this is the same pointer value, but this is false. Let us check. It's not equal to this, false. This should be true. So the ID is not being. Oh yeah, because this is a pointer, so the ID changed in both. So we can do old ID e2 ID equals e2.id, right? There we go. These guys are pointers. Just do this. Okay, and I need e2 ID. Okay. Nice. So we have the same pointer, but the ID changed in between, and this is what we expect. And let's just make sure. So let's do a entity.get generation, and let's get a toID generation. Line toID generation, get index toID as well. And then here we just do the same thing, but for A3. So the index should be the same, generation should be +1. Why are you supposed? Okay. And we have index 1, yes, because that's the second entity, generation 1, same index, generation 2, exactly. This is exactly what we want to do like. So I think this is good stopping place for today. Still sick, so I'm being tired, but it's nice progress. So we have generation indices ticked off. We have this, and we already did, so getting new entities, creating them, getting an entity by ID, freeing an entity, and creating a registry. I think this is good. Is there anything we want to do? It's easy. Yeah, we have a free list. So I like that. What should we do? Get free. Oh yeah, we need to reset the thing. So when we create a new entity, maybe when we free, to be honest. When we come to free, we're already here. You can do components equals slice it to 0. I don't get anything, just clear out all the components. Yeah, free can handle that. So for example, again to test, let's do, so we tested this, we don't need this not components, and E3, E2 comps. So if we get entity 2 and before we free it, let's do E2 components equals add, how do you do it? Components append, let's add like a transform. So we have this. Now when we get E3, we should see now. Nice. One is where? Maybe the other way around. Oh, let's do this. Free entry, free after we add. Yeah, 0 out of 1. And so I assume if I do, I think that's the capacity. We do len, we just won't find it. Yeah, len is 0. So it's the same array. This one has 1 entry, this one has 0, but we still have the capacity. We might want to clear the capacity to avoid issues later on, but we can do should we recreate the array to remove all the entries from memory? I think that's safest, honestly. Actually, let's just do that. It should be 0, 0. Yes. I think it's safer and to, allow all stuff to be garbage collected. Not to have like, oh, my component should be destroyed but still alive because it's in the list. Right. So I think this is a great stopping point. We can remove some of these stuff we got and push the GitHub. Generational indices plus get free entity plus free list. Nice progress. I think maybe next time, if I'm not mistaken, this might be more or less enough for us to actually use the component system. So we can apply it perhaps on Flappy Bird. You can see. Right, everyone, thank you so much for coming. I'll see you maybe next week.